Something is happening right now in China that aviation companies do not want you to know about. Imagine boarding a train in Beijing and arriving in Shanghai faster than a passenger jet could make the same journey, including all the airport hassle. Sounds impossible, right? Well, China just made it real. While most countries are still figuring out basic high-speed rail, China has built a machine that travels faster than a Formula One car, a bullet train, and most small aircraft combined. Today, I am taking you inside the most revolutionary transportation project of the 21st century. A train so fast it is rewriting the physics textbooks. What you will discover at the end will show you why the entire global transportation industry is in panic mode. Let's get started. Let me paint you a picture. It is 2025. Somewhere in a secret testing facility in Shaanxi province, engineers are about to do something that was considered science fiction just 5 years ago. They're about to launch a passenger train at 1,000 kilometers per hour. That is 621 miles per hour for my American viewers. To understand how insane this is, let us compare. A Boeing 787 cruises at around 900 kilometers per hour. A Bugatti Chiron, one of the fastest cars ever built, tops out at 490 kilometers per hour. This train is nearly double that. We are talking about ground transportation moving faster than most things in the sky. But here is where it gets wild. This is not just a prototype sitting in a lab. China has already built 2 kilometers of operational track, and they are planning a commercial route that will change everything. The technology behind this monster is called the T-Flight Maglev Hyperloop system, and it is nothing like any train you have ever seen. How do you make a train fly? Here is the thing most people do not understand about extreme speed. The biggest enemy is not engine power. It is friction and air resistance. Traditional trains, no matter how powerful, hit a wall at around 350 to 400 kilometers per hour because they are literally fighting against physics. So Chinese engineers asked a simple question. What if the train never touched the tracks? What if there was no air to push against? The answer is magnetic levitation taken to an extreme level. This train uses superconducting magnets cooled to minus 196 degrees Celsius, colder than liquid nitrogen, to create a magnetic field so powerful that the entire 200-ton train floats 35 millimeters above the track, not touching anything. Zero friction. Pure magnetic suspension. But that is only half the solution. The real genius is the vacuum tube. Picture this. The train travels inside a massive tube where 90% of the air has been removed. It is not a complete vacuum because that would be impossible to maintain, but there is so little air that air resistance falls by 90%. It is like swimming through honey versus swimming through air. When you remove the honey, suddenly you can move at speeds that seemed impossible before. The engineering nightmare nobody talks about is this. Building a train that floats is impressive. Building one that floats at 1,000 kilometers per hour inside a vacuum tube is where things get absolutely crazy. And Chinese engineers had to solve problems nobody had ever faced before. The first problem is thermal expansion. When you remove air from a tube that stretches hundreds of kilometers, temperature changes can cause the metal to expand and contract by several meters. Imagine trying to keep a floating train stable when the tube itself is constantly changing size. The solution is a sophisticated sensor network that monitors temperature every 10 meters and adjusts the magnetic field in real time to compensate. Problem number 2 is passenger safety during emergency stops. At 1,000 kilometers per hour, hitting the brakes means dealing with G-forces that could seriously injure passengers. The train uses a multi-stage braking system that combines regenerative magnetic braking, aerodynamic flaps, and emergency track sections where air is rapidly reintroduced. Even in a full emergency, deceleration never exceeds 0.5 G, roughly what you feel during a normal car stop. Problem number 3 is what happens if the vacuum fails. This is the nightmare scenario. If air suddenly rushes into the tube while the train is at full speed, the impact would be catastrophic. Chinese engineers installed a triple redundant vacuum maintenance system with emergency pressure equalization chambers every 5 kilometers. If one section fails, the train automatically slows to a safe speed before entering the affected zone. But here is what is truly mind-blowing. Despite all this complexity, the system is designed to be more reliable than conventional high-speed rail. How? because with no physical contact there is virtually no mechanical wear. The only parts that degrade are the vacuum pumps, and those can be serviced without stopping train operations. What 1,000 kilometers per hour actually feels like. Let us talk about the passenger experience, because this is where things get really interesting. You might think traveling at 1,000 kilometers per hour would feel like being inside a rocket ship. But according to test passengers, and yes, they have already had people on board during high-speed runs, it feels eerily smooth. Why? Because there are no wheels hitting track joints, no vibrations from wind resistance, and the magnetic suspension absorbs even the tiniest irregularities in the guideway. Test passengers report it feels like floating in a luxury hotel room that just happens to be moving faster than a jet. The windows are actually giant OLED screens showing the outside view, because at these speeds real windows would need to be so thick and small they would be useless. But here is the clever part. The screens can display anything. Traveling through a tunnel at 1,000 kilometers per hour. The screens show you a simulation of flying over scenic landscapes. It is transportation meets virtual reality. The cabin pressure is maintained at a sea level equivalent, and temperature is controlled to within 0.5 degrees Celsius. There is even a sophisticated motion prediction system that adjusts seat angles microscopically to counteract any acceleration forces before passengers can feel them. One test engineer described it as the uncanny valley of transportation. It is so smooth that your brain struggles to process that you are moving at all, until you look at the speed display showing 4 digits. Here is where this goes from impressive technology to genuine revolution. China is not building this for fun. They have a very specific route in mind that will completely disrupt both domestic flights and conventional rail. The planned Beijing to Shanghai route is 1,300 kilometers, and on this new system it takes 78 minutes total, door to door, because the stations are integrated directly into existing metro systems. Compare that to flying. Beijing Capital Airport to Shanghai Pudong Airport is 2 hours flight time, but add 90 minutes for security and boarding, 30 minutes for baggage claim and exit, plus travel time to and from airports, and you are looking at 4.5 to 5 hours minimum. The Hyperloop train cuts that by nearly 2/3, but the route does not stop at Shanghai. The master plan includes extensions to Shenzhen, Guangzhou, and eventually Hong Kong, creating a megalopolis of 200 million people, all within 90 minutes of each other. For context, that is like being able to commute from New York to Florida for breakfast. The economic implications are staggering. When you can live anywhere in this network and work anywhere else, property markets will fundamentally change. Why pay Beijing prices when you can live in a smaller city and commute in 30 minutes? The technology arms race nobody saw coming. What is fascinating is how this project has triggered a global response. Japan, which basically invented modern high-speed rail, has announced an acceleration of their own Maglev program. Their L0 series was already hitting 603 kilometers per hour, and they are now targeting 1,000 kilometers per hour capabilities by 2035. Europe is taking a different approach. Instead of competing on speed, they are focusing on network coverage. The European Ultra-Rapid Train project aims to connect 50 major cities with 500 kilometers per hour service, slower than China's Hyperloop, but with far more destinations. And then there is the United States, which is, well, still arguing about funding conventional high-speed rail. The Las Vegas to Los Angeles project has been on the drawing board for 15 years. Meanwhile, China built this entire Hyperloop system in under 7 years. But here is what the competition is missing. This is not just about speed records. China is building an entirely new transportation infrastructure that will define urban development for the next century. When a train system operates at airplane speeds with metro-level convenience, the entire concept of cities changes. The dark side of hyperspeed. Now let's talk about what the promotional videos do not show you. Building a near vacuum tube train system is not just expensive, it is catastrophically expensive. Early estimates put the Beijing to Shanghai route at $100 billion. For comparison, California's conventional high-speed rail project, which is nowhere near completion, is already over $100 billion for a much shorter, slower route. Then there is the energy consumption. Maintaining a near vacuum in hundreds of kilometers of tube, running superconducting magnets, and powering the propulsion system uses enormous energy. This train is an energy monster. China claims it will use renewable energy, but the reality is more complex. The power requirements are so high that the route will need its own dedicated power plants. There are also serious questions about emergency evacuation. If something goes wrong mid-tunnel in a vacuum tube 200 kilometers from the nearest exit, what happens? The official response is that the train can limp to the next station using backup power. Air can then be gradually reintroduced, but this has not been tested at scale. And then there is the geopolitical angle. China is already offering to build these systems for other countries, the Belt and Road Initiative on steroids. That means Chinese companies could control critical infrastructure in dozens of nations. Some countries are excited, others are deeply concerned. Why airlines should be terrified. Let me show you some numbers that explain why aviation executives are losing sleep. A Beijing to Shanghai flight on Air China costs around 800 to 1,200 yuan, about 110 to 165 US dollars, and emits roughly 180 kilograms of carbon dioxide per passenger. The Hyperloop train is projected to cost 400 to 600 yuan, about 55 to 85 US dollars, and emit 40 kilograms of carbon dioxide per passenger. But the real killer is not price or emissions, it is convenience and reliability. Airplanes are vulnerable to weather, air traffic control delays, and airport congestion. This train system operates in a controlled environment where weather does not exist, and there is no air traffic to manage. For routes under 1,500 kilometers, this could make flying obsolete. And in China, that is the majority of domestic routes. We are talking about potentially eliminating 40% of domestic aviation demand. Airlines know this. That is why several Chinese carriers are already investing in the ground transportation sector. If you cannot beat them, join them. The global aviation industry moves about 4.5 billion passengers annually. If even 20% of short-haul flights are replaced by Hyperloop trains over the next 20 years, we are talking about a $1 trillion market disruption. Here's what keeps me up at night in the best possible way. This technology does not stop at passenger transportation. China is already testing cargo variants that could revolutionize logistics. Imagine shipping containers moving at 1,000 kilometers per hour. Fresh seafood from coastal cities reaching inland markets in under an hour. Medical supplies delivered anywhere in the country in minutes, not hours. The entire concept of supply chain management changes when transportation speed increases by an order of magnitude. There is even talk of international routes. A Beijing to Moscow Hyperloop could cut travel time from 8 hours by plane to 3 hours by train. The technical challenges are enormous. You are talking about crossing multiple climate zones, mountain ranges, and political borders. But if China's track record is any indication, impossible just means not yet. And then there is the space elevator concept, not literal space elevators, but using similar vacuum tube technology for cargo launches. If you can accelerate a train to 1,000 kilometers per hour, what about 5,000 kilometers per hour? At those speeds, you are approaching orbital velocity. Some engineers are seriously discussing hybrid systems where trains launch cargo pods that then use minimal rocket power to reach orbit. What this means for you, let us bring this back to Earth. Whether you live in China or not, this technology will affect your life. If it succeeds, every major economy will want their own version. The United States, Europe, India, and Southeast Asia are all watching. For investors, this creates massive opportunities in everything from advanced materials to vacuum pump technology to superconducting magnet production. The supply chain for these systems is still being built. For workers, it changes where you can live and work. If your city gets connected to this network, your commute options expand dramatically. That house you could not afford in the big city, maybe you can now afford one 500 kilometers away with a 30-minute commute. For the environment, this could be genuinely transformative. If Hyperloop trains replace even a fraction of short-haul flights, we are talking about gigatons of carbon dioxide emissions prevented over the coming decades. So here's the bottom line. China hasn't just built a fast train. They have built a proof of concept that ground transportation can compete with and surpass aviation for speed, while being more convenient and potentially more sustainable. The 1,000 kilometers per hour barrier was not supposed to be broken by trains. It was supposed to be the domain of aircraft. But Chinese engineers looked at the problem differently. Instead of making trains faster within existing constraints, they changed the constraints themselves. Is this system perfect? No. It is expensive, energy-intensive, and raises serious questions about safety, accessibility, and geopolitical control. But it is also functional, tested, and under construction. This is not a Hyperloop startup promising technology in 10 years. This is operating hardware moving real passengers right now. The question is not whether this technology will spread. The question is how fast, and whether other countries can catch up or will be left behind in the transportation revolution. What do you think? Would you travel at 1,000 kilometers per hour on land? Could this work in your country? Drop your thoughts in the comments. I read every single one. And if you want to see more cutting-edge technology analysis like this, hit that subscribe button. The future is arriving faster than we thought possible, and I will be here to break it down for you. See you in the next one.